Assembly of the Dynamic Test Instrument Unit, SIU 200D-500D, was completed February 1st at Marshall, with installation of dummy equipment. The unit is for use in both the Saturn 1B and 5 programs. The Dynamic Test Unit was later installed atop the S4B Dynamic Test Stage in Marshall's Saturn 1B Dynamic Test Stand, where it underwent testing as part of the Saturn 1B vehicle. A ceremony at Douglas Aircraft Company's Huntington Beach, California facility early in December marked the formal turnover to NASA of the first S4B stage built by the company. The stage, designated S4BD, was then shipped from the West Coast to the Marshall Center for use in Saturn 1B and Saturn V dynamic test programs. At Marshall, the stage was installed in the Saturn 1B dynamic test stand in mid-January as part of the Saturn 1B vehicle.
At Marshall's Michoud assembly operations in New Orleans, the S1CD dynamic test stage, which had been moved into the stage test building from the horizontal installation position in the plant area on August 25th, received only minor damage when the building itself was severely hit by Hurricane Betsy on September 9th. Cell number 1, where S1CD was installed, fortunately received less damage than the other 3 cells and was quickly repaired. The hurricane damage has not seriously affected S1C production schedules at Michoud. Following checkout and weighing of the dynamic test stage, which is the first Michoud assembled S1C, it was moved from the stage test building to the Michoud barge docks on October 5th for shipment to the Marshall Center. The stage arrived at MSFC on October 14th. In January 1966, S1CD will be installed in the Saturn V dynamic test stand, where preparations are now underway for acceptance. A hydrodynamic support system consisting of 4 large concrete pillars topped by hydraulic actuators with hydrostatic bearings will enable the vehicle to float virtually frictionless on a film of oil during vibration testing simulating flight conditions. Steel bumpers are being erected inside the test stand to prevent the vehicle from sliding off the support pedestals. A roof has also been installed atop the stand to prevent a chimney effect whereby gusts of wind might distort test measurements. Although the structural test stage collapsed in the final test on September 29th, the failure occurred at an acceptable load level. Testing duplicated in-flight loads on the structure at the end of S1C stage boost. Marshall and SNID engineers are investigating the mode of failure. Original plans were for a modification of S2S for dynamic testing, but as a result of the stage loss, the all-systems test stage will be used instead. The second stage was modified at KSC to the dynamic test configuration and was shipped on October 29th to Marshall. After dynamic testing, it will later be returned to KSC for Pad B checkout. At the Marshall Center, the second stage of the facility's checkout vehicle arrived on November 10th from KSC for further use as part of the dynamic test vehicle. After receiving inspection, the second stage was transferred to Marshall's test laboratory for installation in the Saturn V dynamic test stand. The stage was stacked atop the first stage on November 23rd. The third stage was installed on November 30th. The remaining units, including the instrument unit, the spacecraft adapter, and the Apollo spacecraft, are scheduled to be stacked in December to complete the dynamic test vehicle. Configuration 1, or full vehicle testing, to determine bending and vibration characteristics the vehicle will be subjected to in flight, is scheduled to start in January. Test completion is expected by late February. Later, for Configuration 2 testing, the first stage will be removed from the stand and the remainder of the vehicle will be tested to determine its behavior in flight after first stage burnout and separation.
This artist concept illustrates how the Saturn V dynamic test vehicle appears when fully erected inside the dynamic test stand. Configuration 1, or full vehicle testing, began after completion of stacking. The vehicle was vibrated by electrodynamic shakers to determine the bending and vibration characteristics the vehicle will be subjected to during flight. This bending and vibration data is required to verify the adequacy of guidance and control systems design. Several minor irregularities indicating the need for possible engineering changes were discovered as a result of Configuration 1 testing during this period, and additional tests in these areas will be conducted next quarter. Configuration 2 testing, which includes testing the entire vehicle, minus the first stage, will then begin. The purpose of this test series is to verify guidance and control design for conditions which will be encountered after first stage separation.